Okay, in this third problem, we're dealing with a business stats class exam where the scores are approximately normally distributed, with a mean score equal to 82 and a standard deviation of 4.2 points. And we are asked to calculate the following probabilities. Okay, or in the case of part E here, we're asked at what score would 25% of scores be higher than that score. Okay, and in each of these cases, we're going to be essentially using our z-scores as a way to calculate these probabilities, and z just being, a standardized distance there from the mean. Okay, so let's jump right in. Hopefully this is all fairly easy review for you. So let's look at part A, probability that x is less than 70. Okay, so first things first, let's convert this score of 70 to a z-score. And z, you might remember, is equal to x minus mu over sigma, or the standard deviation. And we're given all of this in the problem. Our x is 70, our mean is 82, and our standard deviation is 4.2. And if you plug all this into a calculator, this gives you a z-score of negative 2.8571428, and so on. And what are we looking for here? Essentially, if we were to draw this out on a normal distribution with a mean score of 70, of 82, we're essentially wondering what is the probability that x falls somewhere here on this distribution. Okay. Notice we don't really have a very large standard deviation, so most of the scores are going to fall in this range, right? Within 2 standard deviations of the mean. So now we're essentially finding the probability that z is less than negative 2.8571. And we can find the z-score, or the probability of this z, from the z-table in the back of the book. And this is approximately equal to 0.0021, or 0.21%. So a very, very low probability that our score is less than 70. This might be an interesting question for us. We want to find out what is the probability that somebody failed this exam. They got less than a passing grade, and we can see that that's a very low probability. So that'd be some good information for us to know, especially if we're the instructor for the course. Okay, and let's look at part B. Find the probability that x is greater than 84. Let's calculate or convert this to a z-score, and this is going to be 84 minus 82 over 4.2. That gives us 2 over 4.2, or approximately 0.4762, and so on. One thing to keep in mind here, that the probability, now we're trying to find the probability that z is greater than 0.4762, which is equal to 1 minus the probability that z is less than or equal to 0.4762. Okay. In other words, what are we trying to find here on this graph of the distribution? We're essentially trying to find this area here. Okay, and using our scores from the z table, 1 minus the probability that z is less than or equal to 0.4762 is equal to 1 minus 0.683034, and this is approximately equal to 0.316966, and so on. That's from a calculator, but you'll get something pretty close to that using those z-scores from the table. So if you put something like 0.3170 as your answer, or something very close to that, then you'd get full credit for this part of the problem. Let's look at part C, the probability that the score falls between 70 and 80. Maybe we want to find what's the probability that somebody got a C on this exam. And just to show the corresponding graph here, 82, we're looking for something in this range, right, from 70 to 80. Okay, not drawn to scale, obviously. So let's find our lower z bound here, 70 minus 82 over 4.2, which is equal to negative 2.8571, and our upper z bound, which is going to be 80 minus 82 over 4.2, which is negative 0.47619. And we're trying to find the probability that z is less than negative 2.8571, which is equal to 0.0021, and the probability that z is less than negative 0.47619, which is equal to 0.31697. Thinking about this probability here tells us everything in this entire range, right? But we need to subtract out this part here. And this part in the darker orange is this probability. So we can find our final answer by taking 0.31697, subtracting 0.0021, and we get 0.3149, or something very close to it when rounding. I think if you use the calculator, you'll get 0.314832. So something very close to what we just got. Let's look at part D. Here we're asked, what is the probability that x is exactly equal to 90? And one thing to keep in mind for the normal probability distribution is that this is really only useful for finding ranges. In other words, ranges from, say, what's the probability the score is between 80 and 90, or between 89 and 91, something like that. Because on each part of this number line, we're dealing with a continuous distribution. And so we know that there are, between these two values, there's an infinite number of possible values that x could take on. So what's the probability that x is exactly equal to 90? In other words, that x is exactly equal to 90.0000000, and so on, right? With infinitesimal accuracy here. Well, if you plug this into a calculator, what you'll find maybe, strangely enough, or to your surprise, is that the probability that x is equal to 90 is equal to 0.0000, and so on. In other words, we're taking the probability of exactly 90 and dividing it by the total probability. In other words, the probability that x is equal to something, which is something 1, and this is 0.0000, something very, 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 very small, that essentially is infinitesimally small, and so we get 0 as our answer. Let's move on to part E. At what score would 25% of scores fall above this score? In other words, we're trying to find something in this distribution, say some score here. We don't know what this score is, but where the cumulative probability of everything above it is equal to 0.25. So if we look at our z table, we can find a z where essentially we get something very close to 0.25. And this z-score is, at least this is the closest we can get to this score from the table. We could probably find something more accurate using a probability calculator, something like Wolfram Alpha. We find that it's very close to 0.68. And we don't know what the score is, so let's leave that as x minus the mean divided by the standard deviation. And when we solve for x, in other words, multiply both sides by 4.2, and then once we've done that, add 82 to both sides, then we get x is equal to 84.856, or again, something very close. This is going to get you most of the way there. Now, using a probability calculator, I was able to determine that a more accurate value of x is 84.83286, and so on. In other words, if you put in, the probability that x is greater than 84.83286, you're going to get 0.25. Okay, so if you get something close enough to this, for example, if you just put 84.8 or just 84, I'm going to give you the credit for this question. All right, I will see you in the next one.